Hi, chemistry students. This is your lesson on percent mass of water in hydrated ionic compounds. So as you may recall, certain ionic compounds are known as hydrates. Ionic compounds that have a set number of water molecules, a set ratio embedded in their crystal, are known as hydrates. These ionic compounds are not just wet, they actually have the water inside the crystal in a set ratio. So essentially the water is caged inside the crystal and at a set ratio. For example, here's hydrated 2 copper sulfate, and you can see within the crystal itself there are water molecules embedded within the crystal. So whenever you figure out the molar mass of a hydrated compound, you have to make sure you take into account those waters that are naturally embedded in the crystal. For example, gypsum is a hydrated salt. It contains a specific number of water molecules embedded in the crystal for every unit of calcium sulfate. Gypsum is commonly used in drywall. Now, the formula for gypsum is CaSO4 dot 2H2O, and that dot means that for every 1 calcium sulfate formula unit, there are 2 waters embedded within the crystal. The proper name for gypsum is calcium sulfate dihydrate. Di meaning 2 and hydrate meaning that water that's embedded in the crystal. Again, that dot means that the water is in addition to the normal formula, and so has to be thought of more as a plus sign than what you might traditionally think of a dot in math as a multiplication sign. It is definitely not a multiplication sign. It is an addition sign. So for every 1 formula unit or 1 molecule, ionic molecule, you have this many waters embedded in the crystal. So the dot means the number of water molecules per formula unit embedded in the crystal. And you can see, for example, magnesium sulfate, heptahydrate. Magnesium sulfate is commonly known as Epsom salts, and for every 1 magnesium sulfate, you have 7 waters embedded in the crystal. Sodium carbonate decahydrate. Sodium carbonate is commonly known as washing soda, and it's a hydrated salt. So for every unit of Na2CO3, sodium carbonate, you have 10 water molecules embedded in the crystal. So you do need to remember these prefixes. They are very similar, or they are the same as the ones you learned for naming binary covalent compounds, going 1 to 10, mono being 1, octa being 8, deca being 9. So let's practice naming and writing formulas. So for 1 and 3, you'll look at the name and write the formula, and for 2 and 4, you'll look at the formula and write the name. So you may want to pause the video and see if you can fill that in, and then you can check yourself. So pause now, because I'm about to go on. Here's the key. Lithium bromide trihydrate. Li is a 1+, Br is a 1-, so that's the proper formula for lithium bromide. Trihydrate, you put this dot, 3H2O, meaning there are 3 water molecules per every 1 unit of lithium bromide. This compound right here would be aluminum chloride, hexahydrate, with 6 meaning 6 being having the prefix hexa. This one we just went over, so I hope you got it. Magnesium sulfate heptahydrate. And again, since magnesium is a 2+ and sulfate is a 2-, that's the proper formula, dot 7H2O. And this one is barium hydroxide octahydrate with 8 having the prefix octa. All right, so let's go on. So you should also know one other vocabulary word. It's the word anhydrous. It means without water. When normally hydrated ionic compounds are subjected to very high heat, they can be dehydrated. That's not their normal condition, but you can dehydrate them, which basically means to drive out the water molecules from the sort of cage that they're in the crystal. So CaSO4.2H2O, which is calcium sulfate dihydrate, can be strongly heated, and when it does, these 2 water molecules are driven out, and you're left with CaSO4, and it would be known as anhydrous calcium sulfate, because calcium sulfate is usually hydrated, or calcium sulfate anhydride. Okay, you now have a chemical analysis problem. This is very similar to what we did in the last lesson on looking at percentage mass of an element in a compound. This time we're going to look at percentage composition by mass of water in hydrated ionic compounds. So let's see in the hydrated compound calcium sulfate dihydrate, what percent of the mass of that is due to water. So to do that, you're going to find the molar mass of the entire compound, treating this dot as an addition sign. Then you're going to find the mass of just the water. And then just as you did before, you'll use this percent mass of the water by putting the mass of the water only over the mass of the compound, or the molar mass of the compound, and then times 100 to convert it to 8%. So we're going to find the molar mass of the entire compound by looking on the periodic table and adding up the atomic masses. So the atomic mass of calcium is 40.08, sulfur is 32.06, oxygen is 16, but we have 4 of them. Then we have to add the water of the mass of 2 waters. So 2 times 2 is 4 hydrogen, so 4 times 1.01. Notice I'm rounding all these molar masses to the hundredths place. And 2 times 16 for the 2 oxygens here in the water, 2 times 16. When we add all that together, the molar mass of calcium sulfate dihydrate is 172.18 grams. Remember, the dot here means add, not multiply. So that's the whole. Now we have to figure out the part that's just water, which is of course just this part right here. So if we add just the mass of the water, the 4 times 1.01 and the 2 times 16, the mass of just the water is 36.02. And now we're going to plug it into that equation. And so we'll have, again, the percent mass will be the mass of the water only over the mass of the compound times 100. So the percent mass of water in calcium sulfate dihydrate would be 36.02 over 172.18 times 100, which would be 20.93% of the mass of calcium sulfate dihydrate is due just to the water embedded in the crystal. Let's try one more. Here's looking at another chemical analysis problem, looking at sodium carbonate decahydrate. And again, it's known as washing soda, which is a water softener. Sometimes people put in their wash. We want to find the percent mass of water in this compound. So you may want to pause the video, see if you can figure it out, and then I'm going to show you the solution. So first of all, we have to do the molar mass. So sodium is 22.99, so 2 times 22.99. Carbon is 12.01. The 3 oxygens are 106.08. So that's this part is 105.99. Then we have to put the mass of 10 waters. So 10 times here are 2 hydrogens and our oxygen, which would be 180.20. To find the mass of the whole thing, again, this dot means add, not multiply. We would add them. We would get 286.19. as our molar mass of sodium carbonate decahydrate. Now we have to use our percent mass. We'll put the water on the top, the whole mass on the bottom, times 100. And then you will do that division, and you will find that percent composition of water in sodium carbonate decahydrate is 62.965%. It's an incredibly hydrated compound. So that is how you do these problems.